welcome to the new episode of GitHub Copilot. In today's episode, we are looking at refactoring, how Copilot can help us in refactoring complex patterns or complex code in our code base. Refactoring include many aspects. The different ways we can do the refactoring is endless. We have the various predefined ways of improving the design aspects of our code using different methods like extract method, interface extraction, superclass or subclass extraction, replacement of inheritance or conditions with better design patterns. All these aspects are part of refactoring. So today we will look at few of these scenarios, how Copilot will help us to improve the design of our existing code. Also, along with refactoring, in modern programming world, we use how to refactor the existing code into patterns. So we will look into few of the patterns as well. So it's a marriage between the refactoring aspects and the patterns. So whenever you do a refactoring, how to ensure that it is aligned to the patterns, design patterns, which will address the recurring design problems. So both the aspects we will be covering in today's demo. And I will be touching upon these aspects with the help of few of the different technologies, starting from C#, my favorite, and Java, JavaScript, Python aspects. So let us move to the demo angle. So I am starting with a C# code base where we are doing the initial simple factoring aspects. After that, we'll go for a specific refactoring aspects which we discussed right now. So let me start with the initial one. There is a method defined here. As you can observe that I have a list of sellers available, and I'm going to loop through each object or each of the seller in my list and check whether the seller is small seller and then add them into the another list. That is what we are doing here. So whenever you loop through a list of sellers, it's always advisable to look for a link query instead of going through the for each kind of statements. So as a developer, I am aware of that. So let us see how we can take the help of Copilot. So I'm going to Copilot Chat and asking Copilot, refactor my code. So the Copilot start thinking about this one. So it's redefined using, refactored the code using the link queries. Instead of this 5-10 lines of code, it came up with a single one-liner thing, and it gives the performance as well. It's not only the readability angle, more link-based procedure will give a more better result in terms of performance as well. Now, the normal concept of refactoring, whenever we look at a refactoring of a legacy code or a complex code, we look for defining multiple methods out of that. So I don't have a very complex code base here. I'm using this sample code which is doing multiple operations. If you see, a create seller is my method which contain some verifications, required field verification, and also it's checking whether the seller is already existing. If not, it's going to add the seller to my context. So that is what it's doing. So let us see how it supports the refactoring of this code. Refactor my code into multiple methods. That is what we normally do. So we capture the concepts under different methods so that the maintainability will be very easy kind of thing. So here it is managed to divide into two different methods. One is for all kind of tests, validations, that is a required field validations, and it's automatically linked to the first one based on the code base. So there is no need for you to divide again establish the dependency between the methods. Instead of that, it's able to establish the dependency here. Sometimes if you have very complex method, and if Copilot came with these kind of two methods or something, and you knows the functionality, maybe taken the help of Copilot to explain the code and understand the logic of the code, then you can ask Copilot to define whatever the suitable method you think so, even some additional methods as well. So let me ask that way, refactor the code using various methods for validation. Then I'm doing is adding to the context, and I don't have an update or delete, so I'm asking Copilot to define these methods as well. So I need a validation, add, then create seller is the addition itself. I can say exist checking also, but let me add this way. So there are two methods and two new methods I have asked Copilot. So let us see how it is coming up with the refactoring aspect. So the validation is changed into a new file method, validate, and they defined a create seller as it is, and where it validate and add it, the remaining code is same. And when it's update also, it's used the similar kind of context, and it's invoked the validation as part of update. I haven't asked them to do any validation, but Copilot is able to link it. It's validate the seller, then do the update and the delete as well. In delete case, it's not doing any validation of the name email exists because it's an existing record. It's going to delete the same. So this is how you can take the Copilot to support your traditional multi-method refactoring approach. So let us move to another aspect. So sometimes we do the refactoring to improve our productivity or the performance of the application. So if you look at this method, it's a multiple if statement. As you know, if you add multiple if statement, it's not high performance. In case my customer step is finished, it execute each of these steps, then it comes to here. So the execution of all previous steps add upon my performance overhead. So let us see how Copilot is going to optimize it. Refactor to optimize performance, or just say refactor, it will work. As you can observe that it's replaced all if statement with switch statement. So if it is finished, it directly comes here and execute this the block only. It will not go to any other blocks. In this case, it's execute each of the conditions first to check whether it is true or false. So this is another optimization angle how you do the refactoring aspects. So let us go for one more small one, where I have another method, small seller verification, where I am doing a seller exist or not kind of small seller or not kind of checking and returning a result. If you look at here, unnecessary, I use this result field. There is no use actually. It can be combined internally using a link or a return statement. That is a better approach. So let me see how Copilot can help me or not. Refactor my code. Yeah, it's used a link query properly. So if it is any of these contain small seller, then send that one. If it is true, send true, otherwise false. Whatever it's the output, it's sending that one. So the explanation is also available here. Even you can prompt further if you need a more appropriate result kind of thing. So let us move to, as we seen in the deck, we have different predefined methods like extract method, extract the subclass, or replace with a query, substitution algorithm, many ways of refactoring. So I'm moving to a Python file to demonstrate some of these things. So I'm starting with this one where I'm asking Copilot to how to extract a method out of this. So let us see how it's extracting the method. Refactor my method using extract method. That is the approach we use for refactoring. So it's going to extract it. As you can see that the print banner, print details, the print details is taken as a separate one, and these two lines are extracted into a separate method and invoked from the first method. So the first method looks very neat and clean. It's going to print the banner and the details. Internally in the details you may have multiple print statement or anything, that is fine. So it's a simple example, but extract method is very useful when you have a heavy or multi-line statement complexity involved. This will be one of the pattern or one of the extraction methodology we use for extracting the method. The next one is we have a pixel delivery where we are using some of the two methods. So let us see how to refactor this one. So in the first one, I'm using this second one just for a checking purpose and returning the value. So it's going to a refactor using inline method. Why we need two methods? It's a simple verification kind of thing. As you can observe that instead of this one, it's directly taken this statement into here and replace it. There is no need for this additional method because it's a simple statement or a condition which we can encompass here as an inline method itself. So that is another way of doing a refactoring aspects. Now going to the next one, here we have some base price and we are comparing that for multiplication angle, so calculating some total calculation kind of thing. So here we try to replace the query. So it's not able to do. Let us see, refactor the code by replacing with query. So let me see, I prompted saying it's a refactoring aspect we are doing. So it's able to do this replacement. The discount is calculated using a query and that is used internally. There is no if else statement requirement here. Internally it's calculated based on this discount validation. So this is how you can refactor the some kind of complex conditions or anything using a query method. Then the last one, let me go for this one. There are multiple if statement and a for loop and everything. So let us see how we can refactor this one. Refactor using substitute algorithm. So I'm going with the substitute algorithm where it will take all these candidate different names into there. So the candidate names are here and each of the candidate, if it is inside this one, return the person kind of thing. So it's substituting the if statement with the inner things kind of thing. So it's a substitute refactoring technique. If you read through that one, you will understand how you can refactor using the substitute technologies. Then let us see how we can use the help in a Java program. Here I will be going through one or two examples, starting with the person one, where you have a person with a name, office, area code, number and a get telephone number. So let me try to get a refactoring here. I'm going to refactoring to extract the class. Refactoring by extracting class. The intention is I have two aspects. One is the person's name and also the telephone number the combination of fields. It's not a single field, multiple fields are there. So I'm planning to extract these telephone numbers into a separate class altogether. That is why refactor by extracting class. So as you can observe that the person class is defined properly with the get and the name field and the getter associated with the name field, and phone number is going to get it from the phone number as a class. So it's extracted the phone number fields, these two fields, that is here office area code and the number, into a separate class, and it's properly combined that and getting it back. So get formatted number is coming from here. This one, telephone number, is the formatted number that will be invoked here. So it's linked these two things, and phone number is the entity used for linking the dependency between two classes. So this is the extraction of class technique. It's an extract class refactoring technique which we used in this particular case. So next one is this one, potential energy, how to refactor, especially when you have some hard-coded values. Most of the time you need to check for the hard-coded values and do the modifications. So refactoring time we do that one. Instead of that, you can ask Copilot to refactor it. Combine, it's not only one method. In our case there is only one constant, but if you have multiple constant, it define that constant and use that as part of all calculations. So any change in the constant, do it one place, and all following areas we use this constant names so that it's easy for us to maintain it. And going to the next one, where we are going for nested conditions. Here you can see there are multiple conditions and it's getting nested. If, else, if, else, if, else. So it's nesting the conditions. So let us see how it refactor it. We normally use a guard clause for replacing the nesting aspects. Let us see whether Copilot will be able to come up with that one. Looks fine. So it's defined the employee class. Then dead amount is dead. If the employees get pay amount is a dead employee, separated employee, retired employee, normal employee. So all these different payments, it's encapsulated as part of the one class employee, that is an abstract class, and then all the subclasses will be implementing this abstract class. So you create an object of employee and pass the details. According to the details, it's pick whichever is the implementation appropriate. So it's a neat and very clean approach. So this is called replace conditional with polymorphism refactoring technique. This is another technique used by refactors, mainly the developers who are doing the refactoring of inner or the multiple conditions. So nested conditions can be refactored by this polymorphism. This is another way also you can apply it. In this case it's more appropriate, so it's getting applied accordingly. So let us move to the next one, where we apply the same polymorphism. Here it's a nesting room. Here also we have a nested kind of values. So let us see how we can do a polymorphism here. So this is my class and I am going for refactor using polymorphism. So again going to define an abstract class. Exactly the same approach we taken. The abstract class and the implementation is separated in different ways. Here also you have an abstract class word and it have an abstract method get speed, and each of the implementation, the get speed is calculated in different according to this condition. If it is African, there is a base speed minus load factor into number of coconuts or something like that. So Norwegian Bluebird, another implementation. So it's defined the abstract class and the implementation in different subclasses. So again, it's a replacement of the conditions with the polymorphism refactoring technique. So both applies in a nested loop as well as in a different conditions which meet the polymorphism approach can be replaced this way. It's a proper refactoring approach we are taking account. So we talks about refactoring using C#, Python and Java. And sometimes we encounter the functional programming. So here I have a functional programming written in Clojure. So this simple functional programming, normally in a functional programming we use lot of nested conditions and if statement, while statement, when not, all these things. So let us see how Copilot can help here in refactoring this one. So I am asking the traditional refactoring approach, refactor into multiple methods to make it more readable. Due to all this nesting, it's very difficult for us to understand the logic. One of the brackets skipped, then it's gone. Where it landed, we don't know. So I'm asking Copilot to help me to refactor, make it more readable. So it's defined 3 methods, 1, 2, 3, and it's obviously linking each other these methods. So here this method, insert email for users if not exist, is invoking insert emails for users that may be coming somewhere else, or users nickname. This is nickname one is used here. User nickname by name, that is used there, and this method is used here. So instead of going for a nested approach, it's replaced one, and it's given the explanation also, all three, how it's linked, what exactly the functionality capture and everything. So if you are dealing with a functional programming approach, you will be able to use Copilot for supporting you in the refactoring aspect. Once it's done the coding, you review it and incorporate as part of your requirements. So let us quickly see one of the UI framework as well, that is a JavaScript angle. This one is a React component where we are having a dashboard with multiple hooks are used here, use state and effect. These are the hooks we used and defining the dashboard here. So let me see how Copilot can help me to refactor this using custom hook. So I am asking Copilot refactor using custom hooks. So hooks are the way we use to segregate the functionality into reusable functions in React. So as you can observe here, it's define a custom hook. Any hook in React will start with use. That's a keyword used for that. Use repos is my custom hook. Internally use a number of hooks. The state and the effect hooks are used internally. And this one, use repo, is properly used in my dashboard. So the dashboard code looks very clean, neat and readable format. If you want some kind of documentation as well, add documentation to above refactored code. Cool. You have the explanation as well here. Now you can see that there is a custom hook we defined to handle all the logic in the state and the effects angle, and the actual component for displaying the list of repositories in the dashboard here. So both the refactoring as well as documentation completed here. So you can use Copilot for normal programming, functional programming, now the UI angle, React programming as well. So let me end with few of the pattern aspects. So I have again a JavaScript here, and I'm going to use refactoring as well as pattern. So in this case, I am going to use the bridge pattern, which will be used for bridging the information kind of thing. So I am asking Copilot, refactor the user information using bridge pattern. Remember, you need to be aware of the patterns. There are n number of patterns are there. Bridge is a way of extraction of class kind of thing, where it's bridge the different elements together, where in this case the user aspect, the user element is completely captured as a separate class instead of a constant. It defined as a class with the proper fields, constructor and get elements, and in the favorites that is another element used here that contain a different internal fields that is again captured as another class. And these two, the favorite is used internally in user, and user component use that user class and defined properly. Instead of a constant definition with hard-coded values here, you can replace that using a segregated classes, that is the bridge pattern normally. You can read here, it separate the user information, more details are provided here. So that is one of the design patterns, and let us go for another design patterns for this active users. So I'm asking Copilot to refactor using extraction. So I want to extract the things, especially the anonymous function defined here, that is active users as a constant, and it's a function, anonymous function, that needs to be replaced with a proper implementation. That is what extraction will do. So extract function refactoring pattern, that is the one applied here. Whenever there is an anonymous method, you can replace that with a proper method and invoke it properly in the actual statement wherever it's required. So this is the implementation of a extraction of the functions. That is again a design patterns approach. And let us end with another design pattern. So I am going to go with this create seller. We did a multiple refactoring on this method earlier. Now let me ask Copilot to help me to refactor along with the strategy pattern. So strategy means whenever there is many fields comparison, here you done two of the validation, name and contact email, but tomorrow you may add some 10 other fields. You need the similar kind of validations. So the strategy pattern is the complex validations you can segregate into a different methods and use it. So let me ask Copilot how to help me refactoring the code using multiple methods. That is what we did earlier, and use strategy pattern to validate the fields. So the validation of the fields goes to a strategy pattern so that we will be able to consume it later. Whenever a new field comes, you will be able to use it. Cool. It's defined in a very proper manner. If you notice that it's defined an interface like field validator with a valid method, that is an abstract method inside the interface declaration, method declaration in an interface. Then that interface is implemented for name and email validation. So the implementation logic will be different for both the elements, and it's consumed as part of list of validators. So that's the abstraction level. You have the validations captured as list of. So tomorrow if you add one more validator, use the same interface to implement, and you can pass that as part of this one. There is no need to change any of the internal aspects. This will take care of the validation of all kind of validators. So you just need to invoke which validator you are doing kind of thing. And it's used internally here, the seller validator functionality, this class, and the internal validation method as well is used, and the created the seller. So that is a strategy pattern used here. And obviously you have n number of patterns like factory, the singleton pattern normally used by all of us. So try it out how you can use Copilot, how you can take the help of Copilot in refactoring the legacy code base, or even the modern applications may have some of the complex situation, how to improve the readability, maintainability, overall design of your code, along with the concept of patterns, add the abstraction of reusability or extensibility. Here also the strategy pattern help us to extend this to future needs. That's what we are doing. Thank you all. Bye.